So we'll look at a few kind of new things today. Mainly the new things today, average speed, that's one. And approximations, basically getting a sense of roughly how long one should take or roughly how much distance one would travel at a particular speed in a certain amount of time, those kind of things. And then the second half of this session will basically be kind of an amalgamation of all the things we've been discussing since yesterday, and then questions which require us to apply those things. Sure. So to start off, I have a question for you. Go ahead, take a minute or so, answer this. Another question, this time share your answers in the chat. Sure. So let me ask you guys, I'll start with the previous question. Netik, how did you go about this question? The previous one?
I just simply did I just applied the formula यहाँ पे and then just converted into minutes.
Yeah.
Please to D.
Yeah. Yeah. How about this one?
This one, earlier I was trying to somehow use ratios, but I was not able to. Then I just used that both the times equal to 42 and then just distance upon speed. Both of them, if I add
D upon 140 and then 3D upon 70.
Yeah. And again, converting 42 minutes into hours. That's how I went about it.
So algebraically, basically, huh?
Yeah.
Okay, fair. All right, to stay with me, Netik. It's like I said at the beginning, one of the things I want to discuss today is, do you even get a sense of how long it would take or how much distance or at what speed would the person have been traveling by looking at the numbers? So, for example, let's say if a person is driving at this speed, 100 kilometers per hour, and drives for 50 kilometers. How long will the person take?
Half hour, 30 minutes.
Half an hour, right? So half of 100. Okay, this is perhaps straightforward to see. How about this now? Don't need to give me an exact value, but tell me roughly.
More than 1 hour.
More than 1 hour, good start. Would it be more than 1.5 hours also?
No, less than 1.5 hours.
In 1.5 hours, they would have covered 150 kilometers.
Yeah.
Right? So less than 1.5 hours. Okay, good enough. How about this?
More than 2 hours.
More than 2 hours, little bit more than 2 hours. Okay. 60 kilometers per hour for this long. Then how much distance would be covered? Again, no need for an exact value.
More than 120.
More than 120 kilometers. If you were to give me an exact value, then?
Then again, I just convert into like it's 2 hours 12 by 60 into 60. Something like that.
Yeah. You could do that. Or realize 60 kilometers per hour. This is perhaps the cleanest number we can have in terms of speed. How many kilometers per minute?
1 kilometer.
60 minutes, so 1 kilometer per minute. So
Yeah.
in 2 hours, that's 120 kilometers. In 12 minutes, how many kilometers?
12 kilometers.
12. So overall, 132.
Yeah.
Okay. So now, this question, how many minutes does it take to travel 120 miles at 400 miles per hour? How many minutes, right? So would it be more than 30 minutes, less than 30 minutes? Let's start with this.
Less than 30 minutes because it's traveling less than 200 miles.
Would it be more than 15 minutes or less than 15 minutes?
More than 15 minutes because traveling more than 100 miles.
Right. In 15 minutes, they would have traveled exactly 100 miles. Yeah. So our answer has to be more than 15 minutes. Gone, done. right? So again, I can't highlight this enough. Often
Hmm.
the reaction is, oh yeah, but this was somewhat lucky. What if the options were different? What I believe is that these are the skills that are really being tested, right? Do you
Hmm.
get into the calculations of it all, or do you realize that, oh, anyway, it's going to be more than 15 minutes? And I believe that the options were specifically designed for that purpose. Chalo, theek hai. This question now. So first, let's make sure we've got everything correct. Nitik, let me explain for a couple of minutes, then I'll call you back. A portion of an automobile test track is divided into segment A, B, and C. Fine, there's a track like a road, and it's divided into 3 sections. In that order, okay. In a performance test on a car, the car traveled segment A at a constant speed of 140 kilometers per hour. Fine. So let's say there's a road. There are 3 segments. This is segment A, this is segment B, and this is segment C. The first portion at 140 kilometers per hour. Immediately after this, the car rapidly slowed on segment B. So it went through a phase of deceleration and then traveled on segment C at a constant speed of 70 kilometers per hour. So for segment B, there's no constant speed, and I'm not really told anything about the speed except that they slowed down. The length of segment C is 3 times the length of segment A. Okay, so they're comparing the length of this portion with the length of this portion. So C is 3 times. It's much longer. Fine. And it took a total of 42 minutes for the car to travel both segment A and C. I'm starting to notice a pattern. They're only talking about these 2 segments, A and C. They're kind of ignoring B. Fine. They've told me the speeds in those 2 segments. They've told me a relation between the length of those 2 segments. Now they're telling me the total time it took the car to travel in those 2 segments only. B is not included here, right? A total of 42 minutes for the car to travel both segments A and C. B is not included. It's not for the whole distance. It's just for those 2 portions. Select the length of segment A in kilometers and select the length of segment C in kilometers. Make only 2 selections. Fine. So I have to find how long is segment A, how long is segment C. So the algebraic approach, let's start with that. Let's say this distance is D, then the distance of segment C becomes 3D. So basically, how long would it have taken the car to cover segment A, distance upon speed? How long would it have taken the car to cover the segment C, distance upon speed? And this is equal to 42 minutes. These are in kilometers per hour. So then let me convert this also into hours, right? Then it's an equation. It's a matter of solving. And in the end, you get D equals 14, I think, 14 kilometers, right? If D is 14, then 3D becomes 42. Done. So this is certainly one way to handle it, right? Let me be very clear. There's nothing wrong with it per se, right? But if we restrict ourselves to this, that's an issue, right? Then what are you learning through the question if you're just applying things that you already knew? So now, here's a few things that I could understand. And Netik, maybe you can assist me here.
Yeah.
Segment A and segment C's relation between them of the length is given, right? Segment C is 3 times as long. So just based on that much, nothing else. Can I understand anything about the options?
Yeah, so they will be in the ratio 1:3.
Right. So basically, now I can pair up options.
Yeah.
So what pairs, can you tell me what pairs we get?
8 and 24, 14, 42, 42, and 126. And 24
Right.
and 42 also.
8, 24, 14, 42, 24, 72, 42, and 26. Yeah. So I have 4 pairs. So still quite a few pairs, right? It's not like, oh, the answer is jumping out to me, at me, but still, let's stay with this. Now I talked about getting a sense of how long it will take. So if the length of segment C is, let's say, 72 or 126 kilometers. And remember, in segment C, they're driving at 70 kilometers per hour.
Right.
How long will it take them to cover just this segment alone? Roughly.
The 70 to 1?
Yeah.
Nearly 1 hour. Little more than.
More than 1 hour.
Yeah.
Here also definitely more than 1 hour.
Yeah.
Whereas we are given that the total time is 42 minutes.
Hmm.
So if one segment already is taking more than 1 hour, then the total time can't be 42 minutes.
Yeah.
So which pairs can we reject now?
24, 72 we can reject. And 42 and 126 as well.
2 pairs gone, 2 pairs left.
Hmm.
Now, whatever the distances are, what do we know about these distances? We know at what speed they drove for those segments. And we know that the total time is 42 minutes.
Yeah.
Now that I have only 2 pairs left, I'll try to work backwards. I'll try to check, does the total time come out to be 42 minutes or not?
Okay.
So for example, let's try this pair first. Now, forget everything else. Or actually, no, let me elaborate on this. 8 kilometers at 70 kilometers per hour and 24 kilometers at, I think I mixed them up. 8 kilometers at 140, 24 kilometers at 70 kilometers per hour. Right? That's what we have. Remember, our goal is to check, is the total time 42 minutes or not? So, in which segment will they take longer? Let's start with this.
Segment C.
The second, right? Slower speed and more distance. So from both perspectives, they'll take longer. First segment, short distance and faster speed. So let's do one thing. Let's assume for a second that the whole distance was covered at the slower speed only. I want to get a sense of how long it will take. Whole distance means 32 kilometers. So even if they traveled the whole distance at the slower speed, then how long would it take them?
Less than 35 minutes.
Less than half an hour, right? Less than 30 minutes. 35 kilometers would have been in half an hour. Here it will take them less than half hour, or in other words, less than 30 minutes. Now, this is when I'm thinking that the whole distance was covered at the slower speed. In our case, actually, one segment is covered at a faster speed, so the overall time will further reduce. There's no way the time can reach 42 minutes.
The distance should be more.
Sorry?
The distance should be more than get to the point.
Right, correct. So even this pair gets rejected. We're only left with one pair. At this stage, I could mark this answer and move on because there's no other pair left. If I have the time, I'll take a little while longer to confirm. So help me here now. 14 kilometers at 140 kilometers per hour. How much time would that be?
14 minutes.
Careful now. 140 kilometers per hour.
10 minutes.
Okay. So in 1 hour, they do 140 kilometers. We have to figure out 1/10 the distance, right? 1/10 the distance will be done in 1/10 the time.
Yeah.
1/10 of 60 minutes.
6 minutes.
6 minutes. Right? Full hour, 140. 1/10 of that distance in 1/10 the time, 6 minutes. And then this other segment is 42 kilometers at 70 kilometers per hour. So here we'll have, I mean, you can figure it out directly also. What do we get? How long?
Again, 70 by 42 into 60, something like that. So
yeah, not 70 by 42, no? Distance upon speed.
Sorry, 40. Sorry.
42
30,
upon 70
36
hours. Right. 42 upon 70 hours or 42 6 upon 10 hours or 6 into 60 upon 10. So 36 minutes, right? Here also, I could think of it this way that, okay, 35 kilometers will be done in exactly 30 minutes. And then 7 kilometers left. So 42 minus 35, 7 kilometers will be done in 1/10 of an hour. So 6 minutes again, right? So 30 plus 6, 36 minutes. And 6 plus 36 does give us 42 minutes, right? So I've kind of confirmed that this pair works. So my one suggestion to you guys is, when you see questions like this, don't think about what would I do in an exam. At least at this stage, don't go with your instinct and your gut that, oh, let me just create equations as soon as I can, right? Try to restrict that instinct and try to figure these things out. Again, I'm not even saying figure them out so that you can do that in the exam. That's your call that you can take eventually, depending on what you feel more comfortable about, what you feel better about. But if today you are taking a call based on what you're more comfortable with, then anyway, you'll go with the traditional approaches, right? Because you've been using those pretty much all your student life. And these approaches, maybe you've never used or very seldom used, right? So then anyway, the preference would be given to those. So don't evaluate based on your comfort today. If you're not able to fight that instinct, even if you go ahead with equations initially, even then, after you're done with the question, then think about how else could I answer this question? Was there a way in which I could reason out what the answer should be? So smaller, and now one thing in two-part analysis questions, I make sure I double check exactly which column represents what. Because I don't want to get my answer wrong just because I exchanged the answers. Right? So segment A is the shorter segment. So that will be 14 and the other one will be 42. Let's continue then. So Ashima, let me ask you now. Now we look at average speed. So this is the question. Go ahead, read it, and then tell me your answer.
Person drove for 1 hour at 60 kilometer per hour. And then for 1 hour at 40 kilometer per hour, what is his average speed for the entire trip? First hour, he is driving 60 kilometer. Then he's driving 40 kilometers. So total 100 kilometers in 2 hours. So average speed is 50 kilometer per hour.
Fine. Your answer is correct. Tell me, was it a case of that? Did you have an initial instinct that perhaps the answer should be 50, but chalo, let me just double check?
No, no, because average speed will be total distance upon total time. So it might not
Right.
be same. Like here there is some symmetry.
Correct.
But
so was that
yeah,
by
so
chance? The average is exactly in the middle.
Yeah, it's by chance.
So if I change these 1 hour and 1 hour to, let's say, 3 hours and 3 hours, how would you go about that? Three into
That
60 plus 3 into 40.
100 by 6 kilometer per hour.
100 how? 100 कैसे आया?
No, sorry. No, not 100. Yeah, 3. Yeah, it will be the same.
180 plus 120.
Yeah, so 300 by 6.
Okay.
That will again be 50. Yes, it will be the same.
So if I told you it's 13 hours and 13 hours, how would you go about it?
Same. Time, yeah, it will be 50.
So that's my point, right? So do you need to every time calculate 13 into 60, 13 into 40, and then divide by 30? 13. See, one way to understand anyway is 13 into 6, even if you're looking at it mathematically, the 13s will get cancelled.
Yeah, yes.
So if instead of 13, I had 23, 97, whatever number, it'll be there everywhere. So they'll just get cancelled. Sorry, not 13 in the denominator. This is just wrong. 26 in the denominator. So then 13 will get cancelled. I'll be left with 2. Right? So now if instead of 13, I had 73 and 73 at both places, then
Same. It will be the average of two speeds.
the average of the two speeds. So it's not by chance that the average is in the middle, right? It will be in the middle in this case, as long as the times are equal, no matter what the times are. You don't need to calculate every time. With me so far?
Yeah.
All right. Tell me for this one.
A person drove from home to office at 60 km per hour. From office to home at 40 km per hour. Same 50 km per hour.
So my intention was not to confuse you, but in this case, it's not directly 50 kilometers per hour. Before we get into solving, what's the difference in these two cases?
In the first one, the time is same, like equally divided. Second one, the distance is the same.
Correct. So tell me this first. In the first one, is the distance also equal in both the segments?
No, distance is not
In the
equal.
second one, is the time equal in both the segments?
Time is not equal.
In which direction would the time be more?
While returning from office to home,
Because?
because speed is slower.
Correct. Bang on. So here I would have to do some maths, or rather one way to figure out the average. Now I would have to do total distance upon total time. Basically, let's say the distance from home to office is d. The speed is 60 kilometers per hour. What am I doing? This would be the time, sorry. So plus d upon 40. This will give me the total time. So then I do total distance, which is now 2d upon d upon 60 plus d upon 40, right? I cancel the d's. 2 upon 1 upon 60 plus 1 upon 40, 120, 2 plus 3, and then 2 in the numerator, 2 divided by 5 by 120, or 2 into 120 by 5. So 120 by 5, that's 20 plus 4, 24 times 2, that's 48 kilometers per hour. Right? Mathematically, this time the average speed is 48 kilometers per hour. So different. Now, how come in one case we could directly do it, in another case we couldn't? And then should the takeaway be, oh, you can never be sure, might as well always do total distance upon total time? Right? That could be a question coming to your mind. So let me ask you one question. Again, don't calculate directly, but think about it before you answer. Let's say I traveled for 99 minutes at this speed and then for 1 minute at this other speed. Do you think the overall average speed will be 50 kilometers per hour?
No.
Would it be more than 50, less than 50?
It will be closer to 60.
Much closer to 60, because pretty much almost the entire trip I traveled at that speed. It was just for 1/100th of the time that I traveled at the slower speed, right? If the entire trip I'm speeding, and just for a brief moment I went slow, it's not like, oh, suddenly my average speed will just come tumbling down because of that 1 minute, right? It'll remain much closer to 60 kilometers per hour. So the same principle is getting applied in all these cases. Essentially, and this kind of ties into the weighted average workshop I took a while back, that the weights basically for speed, when we have to figure out the average speed, are the times. So if it's equal time at both places, then the average will be bang in the middle. If the time is not equal, then the average will be closer to the speed at which we spent longer time. In this last case, for example, the average will be greater than 50 kilometers per hour. It will be closer to 60 than to 40. By that same logic, already I can figure out. Remind me again, Ashima, which direction took more time?
Office to
Slower, more time. Therefore, since more time was spent at 40 kilometers per hour than at 60 kilometers per hour, the average will be closer to 40 kilometers per hour than to 60 kilometers per hour, and therefore less than 50 kilometers. Now, I don't want to repeat things that I've already covered in averages. At the same time, there's a lot more we can actually unearth here. Let's try it actually. So forget everything else. Just by looking at these two speeds for the same distance, can we comment on what's the ratio? What would be the ratio of their time spent? Not the values, but what would be the ratio of the time spent at these two speeds?
ratio of the time spent for 40 by 60, 2 by 3.
Right.
2 by
Correct.
3.
Correct. Indeed. Right. So same distance. I mean, we could kind of go back to what we discussed yesterday. Speed, time, and distance. Now, if I'm covering the certain distance at 60 kilometers per hour, how long would it take? And then if I keep the distance the same and I change the speed to 40 kilometers per hour, what will happen to the time? If the speed has come down, first of all, the time will go up. Secondly, the speed has come down from 60 to 40. So it's become 4 by 60 times or 2 by 3 times of the old speed. Therefore, the time will become 60 by 40 of the old time. Or, yeah, 3 by 2 times. So the ratio between the times will be 3:2. The new time is to old time. Now, how is this relevant for us for average speed? We started with saying that basically the weights when it comes to average speed are the times. So if it's 1 hour, equal weights, therefore average will be bang in the middle. 10 hours, bang in the middle. If it's 99 minutes versus 1 minute, it will be much closer to 60 kilometers per hour than to 40 kilometers per hour. Now, if the times are in the ratio of 3:2, basically the difference between them will be split in the ratio of 3:2. 40 kilometers per hour and 60 kilometers per hour. This is now linking with weighted averages. I don't want to repeat the whole concepts here, but basically I'll start with this. If the times are equal, 1 hour and 1 hour, the difference between them of 20 is split half and half. So it becomes, the average speed becomes 40 plus 10 or 60 minus 10. Right? The 20 is split 10 and 10. That's the average speed. In this case now, let's say it doesn't have to be 3 hours and 2 hours, but let's say it is, or any times in these ratios, the same principle would apply. The gap of 20 kilometers per hour in the speeds will be split in the ratio of 3:2. So on the one hand, the 20 will be split into 3:2, so that becomes 12:8. Now, since the average has to be less than 50, closer to 40, I can do 40 plus 8, or I could do 60 minus 12. Both ways, I get 48 kilometers per hour. So just by looking at the speeds, I can actually directly calculate the average also. This does use weighted averages. Anyway, even if that's not crystal clear, the one thing I do want you to take away is that when dealing with average speeds, what matters is how long was spent at each speed. And that's what determines where the average speed will lie. So in this case, 60 and 40, as we saw, the time is in the ratio of 3:2. Overall, the average speed becomes 48 kilometers per hour. All right, cool. Let's do a few questions. Go ahead. So the same principle can be applied to this question, right? So what are we given? That Susan drove at an average speed of 30 miles per hour for the first 30 miles, and then at this other average speed for the remaining 30 miles. So I noticed that same distance covered at two different speeds. So first thing I understand then, the question is, what was her average speed in miles per hour for the entire trip? The first thing I understand that she has spent more time driving at the slower speed than at the faster speed. Therefore, overall, the average will be not bang in the middle, but closer to 30. Therefore, three options anyway got. Right? C, D, and E I can anyway reject because the average has to be less than 45 miles per hour. Now, do I need to calculate from scratch between 35 and 40? No, I can actually just figure out directly 30 miles per hour and 60 miles per hour. Basically, the gap is of 30, right? This gap of 30 miles per hour has to be split in the ratio of 3:6 or 1:2. So 10:20, right? So the average speed has to be less than 45. So it'll be 30 plus 10 or 60 minus 20. 40. Okay, let's try one more. Go ahead. All right. Netik, did you get an answer?
No.
Okay. Okay, no worries. Based on
I
what we
could have got basis equations, but I didn't go that way.
Yeah, that's fair. That's fair. That's the agenda. That's the objective. Any answer choices we can eliminate.
I could not figure that out because I was
Okay,
trying.
let's start with this.
Yeah.
What's the question even saying? Can you explain that once?
Yeah, so the question is saying that there's a distance of total 40 miles, and for the half of the distance, a driver drove at 50 miles per hour, and for the other half, we don't know what speed he drove at, but we know the average speed, which is 60 kilometer per hour, and we want to get to know the second half distance's speed. That's what the question is asking.
Right. Okay. So can you think of equal distances at both places? Anyway, the options also reflect that. Do you understand why the other answer has to be, or rather the answer has to be more than 60 miles per hour? Do you get that?
Because if
Otherwise,
it's 50, the average will not be.
The average has to be 60 miles per hour. If one portion is slower, the other portion has to be faster.
Yeah.
In which portion would the driver have taken more time? Remember, it's 20 miles, equal distance.
Now, again, I was thinking through that, but I could not understand that if I don't know the other half speed, then how do I get to know about which half would take the more time? So that's
But I
where
do
I
know that
was.
the speed will be more than 60 miles per hour, no?
Yeah. Okay, yeah.
One speed is 50 miles per hour, the other is more than 60.
Then only the average could be 60, yeah.
So then, which portion would
The
they
first,
drive at?
more time in the first half.
More time here, less time here.
Hmm.
Given this, the average would be closer to 50 or the other figure?
Closer to 50.
Closer
No,
to 50.
yeah.
Closer to 50 because you've spent more time there.
Yeah.
Right? Remember, if I've
More
spent
weighted.
99 minutes at one speed and 1 minute at the other speed, the average will be much closer to the 99-minute speed.
Right, right,
Same
right.
principle here also. So the average will be closer to 50. Basically, 60 miles per hour is closer to 50 miles per hour than to the answer. Let's put it that way. Make sense?
Right. So the answer has to be greater than 70.
Nice. Yes, indeed.
Yeah.
Right. The difference between 50 and 60 is 10. So the difference between 60 and the other figure has to be more than 10 because this 60 has to be closer to 50.
Got it.
So if let's say the other speed was 68 miles per hour, then 60 is closer to 68 than to 50. That's a problem. If the speed is exactly 70 miles per hour, then 60 is bang in the middle. That's also a problem. Yes. So the answer has to be more than 70 miles per hour. Anyway, that much I can understand. Now that I'm left with two options, often when this happens, my next step is to try to plug in an answer and then check backwards. Basically, if the speed is 75 miles per hour, can we figure out the average in that case, Naitik? And what should the average be? For it to be the correct answer, what should the average be?
Midpoint of 50 and 75. No. Again.
For it to be the correct answer.
Okay, so it should be split into ratio of 2:3.
You're right, but I'll interrupt you there. Don't go ahead with figuring out the average. My question is very specific. Basically, whichever answer is correct, how will I check that it's correct? The average of 50 miles per hour and that option should be 60 miles per hour. Right? So that's my check, basically. Is the average of 50 miles per hour and 75 miles per hour 60? Or is the average of 50 miles per hour and 80 miles per hour 60? Does that make sense?
Yeah. But again, how do I do that? I'm stuck at that point.
We'll discuss that.
Yeah.
But one step before that, what do I need to check? I need to check, is the average for option D, for example, with 50 miles per hour, 60 miles per hour or not? If it is, then D will be correct. If it's not, then E will be correct. Does that much make sense?
Yeah. That
Okay.
makes
So now it's a question of figuring out the average, right? 20 miles at 50 miles per hour, 20 miles at, let's say I'm considering option D first, 75 miles per hour. And I want to check, is the overall average equal to 60 or not? Right? So yes, you were onto something. Equal distances at both speeds. So first of all, in which segment would they take more time?
segment 1.
So this segment is more time, the other segment is less time. What's the ratio of the time spent?
3:2.
3:2, right? 3K and 2K, let's say. So now realize these are the weights. So basically the difference between them, between 50 and 75.
Yeah.
If
2
the
is
weight,
to 3. That should be 2.
correct. The 25 basically, 75 minus 50 equals 25. This difference has to be split in the ratio of 3:2.
Yeah.
So we get 15 and 10 basically. Now the average has to be closer to the slower speed, closer to 50 than to 75. So I'll do 50 plus the smaller one or 75 minus the bigger one. And I do get the average speed as 60 miles per hour. It fits basically. Since it fits, it's the correct answer.
Right.
So yeah, some weighted averages concepts I'm using here, which I haven't explained in full detail, right? So that could be an issue. One suggestion obviously is, if you've taken a part in that workshop before, you could go through that content. I know, Naitik, you have enrolled in that, right?
Yeah,
So
I took the recording of that and I watched through.
So yeah, starting point is that I look at the difference between the two numbers. If the weights are equal, if the times are equal, the difference will be split exactly half and half. Which is why, for example, 1 hour at 60 and 40, the average becomes bang in the middle, 50 miles per hour. So in this case, the difference of 25 needs to be split in the ratio of 3:2. So 15 and 10.
Anish, one thing,
Ah.
sorry. Yeah, I just got confused that it should be greater than 70. That's fine. But if let's say it's 70 only, and the distance is same, 20 miles and 20 miles, and this thing is right in the middle, 60 miles per hour. But if the time taken is kind of same, then it can be 60, right?
It can be, but if the distance is the same and speeds are different, the time taken can't be the same.
Okay. Yeah. Yeah. Because that was a bit bothering me, that because when I was solving also, I was thinking even if it's 70, then why not 60 fits in with the 70? But yeah, that makes sense. Time has to be
Right.
there.
It's quite a few things to wrap your head around.
Yeah.
So suddenly kind of brought in some new concepts. Is anyway that underlying concept of weighted average also being applied, and the fact that times are the weights, that itself is also perhaps potentially new. On top of that, but still these things can be understood, right?
Yeah.
First thing, the other speed will be more. Second thing, if the speed is more, the time will be less. If the
Then
time
it
is
can,
less, the average
yeah.
will be closer to the other number. And it kind of builds one on top of each other.
Yeah. So it's kind of advanced weighted average questions. Got it.
Chalo, let's try. We'll do 2 more weighted average questions. Let's try this one. So, average speed again. Jill went up a hill at an unknown constant speed. And then we know that she came down at twice the speed and along the same route. So basically, distances are equal. Her speed was twice as fast. And we are given the average speed was 6 kilometers per hour. Then we're asked, basically, what was the speed coming down? Basically, the faster speed, the double speed, right? So, I mean, the way I dealt with the question was I started with the answer choices. Anyway, that's part of the process. I recommend that you start with scanning the answer choices anyway. So, if let's say 7 miles per hour is the return speed, the other speed would be 3.5 miles per hour. Right? Half the speed going up, twice the speed coming down. And in which direction would Jill have spent more time? Going up, the slower speed. Coming down would have been faster. Therefore, the overall average speed will be closer to the slower speed than to the faster speed. We know the overall average speed is 6 miles per hour. But 6 is closer to 7 than to 3.5. That's a problem. Right? The average speed will be closer to the slower speed. So anyway, this one is gone. In fact, if 8 is the faster speed, 4 miles per hour would be the slower speed. Then 6 is bang in the middle. This is also a problem. 6 needs to be closer to the slower speed, not bang in the middle. This one also gone. Right? 2 options gone at least. Now, I do get a sense that 11 miles per hour and 5.5 miles per hour. The average so close to 5.5 seems a bit far-fetched, right? The average is 6 miles per hour, which is just slightly more than 5.5 miles per hour, right? So I'm thinking that that one seems too big. But yeah, I'm not 100% sure. So the way I solved it, and I will discuss another mathematical approach also, but the way I solved it, 9 miles per hour, then the other portion will be 4.5 miles per hour. So if let's say one side the speed is 4.5, the other side the speed is 9 miles per hour. Now I will check, is the overall average 6 miles per hour or not? Basically, I'll figure out the average of 4.5 and 9. I know that at the slower speed, they would spend twice the time. At the faster speed, they would spend half that time, right? Whatever it is, 2 minutes, 1 minute, 20 minutes, 10 minutes, whatever it might be. So then basically, the difference between the two speeds, 9 minus 4.5 is 4.5. The difference needs to be split in the ratio of 2:1 or 3:1.5. The speed has to be closer to 4.5. So 4.5 plus the smaller value or 9 minus the bigger value. This does actually give me 6 miles per hour. It fits, right? So 9 is the correct answer. Just let me highlight what would happen with one of the incorrect answers also. Let's say you didn't directly choose 9. Let's say you chose 10 first. Then what? The speeds become 5 miles per hour and 10 miles per hour. I have to check, is the overall average speed 6 miles per hour or not? That's the question. The times would be still in the ratio of 2:1, 2K and 1K, let's say. So the difference between the two speeds, 10 miles per hour and 5 miles per hour, the difference of 5 miles per hour needs to be split in the ratio of 2:1. First thing I notice, these aren't clean numbers, right? If I have to split basically 5 divided by 3 times 1 and then 5 divided by 3 times 2, these aren't clean numbers. So anyway, the average won't come to a neat and clean 6 miles per hour. What would be the exact average in this case? 5 plus the smaller value, 5 plus 1, 2 by 3. So 6, 2 by 3 miles per hour would have been the average if the speed coming downward 10 miles per hour. So one more thing, actually, let's say I tried 10 first. One more thing I can understand at this point. Oh, if the return speed is 10 miles per hour, then the overall average is more than 6 miles per hour, which means the return speed should be less than 10 miles per hour. Remember, the speeds both are related to each other. The going speed is half the return speed. So if one increases, the other will also increase. If one is 10, the other will be 5. If one is 12, the other will be 6. They'll both increase. They'll both go in the same direction, right? So if anyway, I'm increasing both speeds, for example, from 5 and 10, if I make them 5.5 and 11, then the average will anyway be more than 6, 2 by 3. In our case, the average needs to be less. So even if I started with 10, I would have understood 10 is wrong. I would have also understood 11 is wrong. Just because the average with 10 is more than 6, right? So the return speed has to be less than 10 miles per hour. In fact, I could apply this from this get-go also, right? With 8 miles per hour, even if I didn't do the other thing, even if I didn't understand that, oh, if 8 and 4 are the averages, how can the average be bang in the middle? Even if I don't understand that, I do figure out the exact averages. The difference of 4 will be split in the ratio of 2:1. First of all, anyway, again, not a clean number. So I won't get 6. Plus, the difference of 4 will be split into 2:1. So I get 4 by 3 and 8 by 3. So basically, since the average has to be closer to the smaller value or farther from the bigger value, 8 minus 8 by 3, 16 by 3, 5, 1 by 3 would be the average in this case. This way also I could understand, oh, since the average needs to be more, the smaller values can be rejected. So a combination of time, speed, distance, and average is going on in these questions. Let me also highlight now a mathematical way to do this. So let's say starting point, I know that, let's say going up and downhill, let's say the speed going up is x miles per hour. The return speed would be 2x miles per hour. So some algebra will be used here. I know the overall average speed is 6 miles per hour. Now, it is tricky, mind you. It might be difficult to follow, but I'll try to explain. how do we get the average? Basically, the difference between them gets split. The difference between them gets split in what ratio? In the ratio of the weights. The times will be no matter what in this ratio only, right? If the speeds are x and 2x, the time will be in the ratio 2:1. So the difference basically between x and 2x, somewhere in the middle, 6 is somewhere in the middle of x and 2x. And that difference between x and 2x has been split in two parts, right? So, in fact, let me start with numbers to explain this. Let's say 10, 50, 10 and 60 le lete hain. Let's say the numbers are 10 and 60, and I have to split them in the ratio of 3:2. What would be the average then? Basically, this difference of 60 minus 10, which is 50, needs to be split in the ratio of 3:2. So, will be split in the ratio of 18 and 12. And then I could do either the smaller number, 10 plus the smaller number, or 60 minus the bigger number. Oh, hold on.
I think the average.
50, sorry, I somehow read it as 30. 50, 3:2 is 30 and 20. So then 10 plus 20 or 50 minus 30. Again, I'm mixing something up. 60 minus 30. So I get the average as 30. Right? So this principle I'll apply there also, or rather, let me do one more step now. Now that I know that the average is 30, basically 30 minus 10 and 60 minus 30. These are the splits. These will be in the ratio of 2:3. Right? So this principle I'll apply to our question. 6 minus x and the other difference, 2x minus 6, is in the ratio 1:2. So 12 minus 2x equals 2x minus 6. 2x, 2x, 4x equals 18. X equals 4.5. Remember, x is the slower speed, so the faster speed would be 9 miles per hour.
Helps. This actually brings more clarity to me, at least. This thing, this mathematics of
Yeah.
calculus.
Okay. So in fact, because I mentioned it, let's do it with the previous question also. The same idea. Without the options, let's try to figure out the average. Let's recap. So what did we have? 20 miles at 50 miles per hour. And then this average we don't know. We do know that the overall average is 60 miles per hour. Now, let's say this other speed is x miles per hour. This is important. The weight, the time will be in the ratio of x:50. Right? The time will be in the ratio of the reciprocal of their speeds. So x:50. Now, 60 minus 50 upon the other difference, x minus 60. This is important now. This is equal to 50 upon x. So 10x equals 50x minus 300. So 300 equals 40x, or x equals 30 by 4. Did I mix something up?
No, I think it's fine. 1, 0 maybe. It will be actually 3,000.
3,000. Okay. So 300 by 4, that's 75.
It's basically taking it one more step further to utilize that ratio to create an equation.
Yeah.
And then, yeah.
The key was, which took me a moment to realize, that this speed is actually the weight also. right? The times are in the ratio of x is to 50.
Yeah.
Chalo, I didn't mean for this to turn into a weighted averages workshop altogether, because if that's all it is, then I know I'm not doing complete justice to that, right? But yes, I do dive much deeper into weighted averages in a few other videos. I do want to continue with time, speed, distance here. Chalo, let's do one more question on weighted averages, just to highlight again a different approach that can be used for a question. Go ahead, try this one. All right, I'll end the poll here. So during a trip, Francine traveled X% of the total distance at this average speed. I'm not a big fan of variables in questions. It does make me slightly uncomfortable. Had they directly said 10%, although I'm not a huge fan of percentages also. Had they said 5 kilometers, 10 kilometers, theek hai. Already you're talking about percentages. On top of that, they're not even giving me a percentage. They're saying X%. Does make me somewhat uncomfortable. But chalo, I am trying to understand that basically a certain portion was traveled at this speed, 40 miles per hour. And the remaining portion and the rest of the distance at an average speed of 60 miles per hour. Fine. Basically, I don't know how much portion was traveled at each speed, but I do know that one portion of the distance traveled at 40, one portion traveled at 60 miles per hour. In terms of X, what was this person's average speed for the entire trip? So anyway, the answer choices also all have X in them. So sure, one approach is total. We have to figure out the average speed for the entire trip. So total distance upon total time, right? Deal with that. How do I figure out the total distance? Let's say the total distance is D. Fine. So what do I know about the total time? What would be the time taken at the first speed, at the 40 miles per hour speed? Remember, the option, we don't have to get a value. The options are also all in terms of X. So I'm thinking, okay, fine. Basically, X% of the distance was traveled at 40 miles per hour. So that's the time it would take to cover that much distance. What would be the time it would take to cover the remaining distance? This is key, that the remaining distance. So let's say 40% was covered at the first speed. The remaining 60% will be covered at the other speed, or 30% and then 70%. Right? So this is one thing to be very clear about, that if one portion is X, the other portion has to be 100 minus X. So you don't need another variable here. This is at 60 miles per hour. 100 minus X% of D. That's what I should have here. So X% of D and 100 minus X% of D, those are the two distances divided by their respective speeds. Right? I could solve this, the D's would cancel thankfully, and I'll eventually get my answer. So this is one way to deal with it. I won't continue with it at this point. So that's one way. Now, another way I want to highlight, when we have variables and options. When we have variables and options, one thing to understand about a problem-solving question is that the correct answer will be correct no matter what the value of X is. It's not like, oh, if X is 10%, then answer is A, but if X is 20%, then the answer would change. No, the correct answer will give us the average speed for any value of X, basically, right? No matter what percent of the distance was traveled at 40 miles per hour, the correct answer will remain correct. So then the starting point for me can become, let me choose an easy value of X. For that, figure out in terms of a number, a value, what the average speed will be. Then check when I plug in that value of X into the answer choices, which ones don't give me that average speed. Whichever options don't give me that average speed, I'll reject them right away. So what should I choose to be the percentage now? I'm thinking, okay, let me keep it simple. Middle 50%. So basically, let's say half the distance was traveled at 40 miles per hour and the other half was traveled at 60 miles per hour. Now, we've already discussed this multiple times. Equal distance traveled at these two speeds, the average will be less than 50. How much will the average be? We just actually calculated already. So the average in this case needs to be 48 miles per hour. So this becomes kind of my groundwork. What will I do with the options now? I will plug in x equals 50 and whichever option doesn't give me 48 miles per hour can be rejected. Mind you, through this, I will only be able to reject incorrect answers. I won't be able to select a correct answer. Because who knows, for specifically this value, maybe multiple options give me 48 miles per hour. Then I could check with another value. But let me start with this at least. Now, my objective with every option is not to calculate the exact value. My objective is to check whether the result is 48 or not. So for example, when I plug in x equals 50 into the first one, 130 upon 2 will be a 5 ending number. Although I see it at 65, but anyway, as soon as I see 180 minus another 0 ending number divided by 2, will either end in 0 or in 5. It won't end in 8. So already I know this one will not give me 48. Therefore, reject. Second one, 50 plus 110 divided by 4. This is going to be very small. Right? 48 is so close to 50. This is somewhere near 25. 110 divided by 4. Not going to give me 48. Also rejected. Third one, 250 by 5 is exactly 50. Doesn't give me 48. Rejected. Fourth one, 600 divided by 65. Now, I won't get into exact calculations. This is where estimations help. Remember, my goal is to check whether the result is 48 or not. My goal is not to calculate 600 by 65. I know 600 by 60 is 10. So 600 by 65 will anyway be less than 10. So anyway, it won't be close to 48. This one also rejected. Actually, I've already got my answer because the other 4 are rejected. But to be sure that I've not made a calculation mistake somewhere, I will check E also. So 12,000 divided by, what do I have? 250. Okay. So 1200 divided by 25. So 12 into 100 upon 25, which is 4. So 12 into 4, 48. None of the other options fit. This one fits. So this has to be the correct answer. Questions? All right.
Anish, just one. If the split is not 50-50, let's say the distance is not equal, how does that impact the average speed? Let's say it's 60%, 40%.
Then you need to calculate it.
Okay.
Because then it's not like, oh, it's equal distance. Anyway, the starting point would still be, you're saying 60-40?
Anything like 30-70, whatever.
No, basically starting point would need to be that in which segment is more time spent.
Okay.
And then remember, the weights will be times. So you need to figure out that.
Okay. Okay.
All right, let's try this one. Indeed, D is the correct answer. So while on a straight road, car X and car Y are traveling at different constant rates. So how come the rates are different also and constant also? Well, constant means that the speed is not changing. Different means that one car's rate is different from the other car's rate. For example, one car is moving at 40 miles per hour. The other is moving at, let's say, 60 miles per hour, right? So their speeds are not changing, but one car's speed is different from the other car's speed. If car X is now 1 mile ahead of car Y, how many minutes from now will car X be 2 miles ahead? So basically, in how much time will the gap between them increase by 1 mile? That becomes the question. right? It's already 1 mile ahead. In how much time will it be? 2 miles ahead. So in how much time will the gap increase by 1 mile? So already I'm thinking, okay, two cars going in the same direction, basically that relative speed thing, right? How much, what's the speed of the faster car? What's the speed of the slower car? In how much time will the gap increase by 1 mile? All right. How many minutes? That's the question. Statement one, car X is traveling at 50 miles per hour and car Y is traveling at 40 miles per hour. So in 1 hour, car X will be 10 miles ahead of car Y. Right? In 1 hour, car X will cover 50 miles, car Y will cover 40 miles. So it'll be 10 miles ahead. So in how much time will it be? 1 hour, 1 mile ahead. I mean, for a data sufficiency question, actually already I know I'll get a fixed value. So already it's enough. Even if I have to figure out the exact value, it won't be very time consuming. In 60 minutes, the car X will go ahead by 10 miles. So 10 miles in 60 minutes. In how much time will it go ahead by 1 mile? 1/10 of 60 minutes in 6 minutes. Right? Statement one alone is sufficient. Second statement, 3 minutes ago, car X was half a mile ahead of car Y. This is now again where these constant rates idea comes into play. That every 3 minutes, the car X will get ahead by half a mile. If in the last 3 minutes it went ahead by half a mile, the same thing will repeat every time. Right? If, for example, in the first statement, after 1 hour, the difference between them is of 10 miles. After 2 hours, the difference will be of 20 miles. We can calculate that also, 100 minus 80. Same way, after 3 hours, the difference will be 30 miles. Basically, this proportion will always remain the same. Same principle in the second statement. If in 3 minutes, basically, the difference increased by half a mile. How do I know that? Because now the car is 1 mile ahead. So in 3 minutes, the gap went up by half a mile. So in how much time will the gap increase by 1 mile? Twice of 3 minutes. So this statement also gives me the value. Right? This statement alone is also sufficient. Indeed, the answer is D. So this is one of the things I've noticed with the new data sufficiency questions in Focus Edition, that I'm not saying you shouldn't or you don't need to, but many questions can be answered without even putting pen on paper. Right? Just if we are understanding what's going on conceptually, if we are clear about things, we can understand, oh yeah, this will give me the answer. Remember, in data sufficiency questions, the objective is not to find the answer. Having said that, it's not the worst crime if you go take a couple of extra steps and figure out the value. I find that many students get very disheartened when they realize, oh man, I didn't need to calculate the value. Essentially, what they're disheartened about is maybe spending some extra time. But if that extra time is helping you get more clarity, then it's worth it. Right? Having said all that, coming back to my initial point, if you are clear about things, in my experience, if not all, at least most of these DS questions can be answered without even putting pen on paper. They can be. That's all. Whether you do it today or not is completely a different matter. Questions?
All good.
Chalo. Let's try this one now. Go ahead. Let me ask you, Ashima, how did you go about this one?
I calculated that how much distance cyclists would have covered in 5 minutes.
1 minute. So let me draw the figure. So basically there's a, let's call it a passing point. And then there's a waiting point. Right? Cyclists traveling in the same direction. past the hiker, then it stops to wait for the hiker after 5 minutes. So, okay. So this much distance the cyclist covered after passing the hiker. So now tell me, what are you saying?
Yeah, so as per her speed, the cyclist will cover 20 miles in 60 minutes. So in 5 minutes, it will cover 20 miles, 20 by 60 miles.
1/3. So in 60 minutes,
20 by 60 into 5. So
in 60 minutes, 20 miles. In 1 minute, 20 by 60 miles. In 5 minutes, 5 by 3 miles, basically. Yeah. Okay. So the full distance is 5 by 3 miles. Okay. Then
So then I calculated how much time the hiker will take to uh travel 5 by 3 miles.
so we know the hiker speed is 4 miles per hour. We know the distance. So distance upon speed will give us the time. So 5 by 3 miles upon 4 miles per hour. 5 by 3 divided by 4, 5 by 12 hours, basically, correct?
Yeah.
So 5 by 12 into 60 minutes. In how many minutes? That's what you did?
Yeah.
Bolo?
This something else. Yeah, this, but so the hiker actually, yeah, also must have traveled. We'll have to subtract 5 minutes from this
Okay.
25.
Nice. So did you miss that bit earlier?
Yeah. Missed it.
Okay. So explain this a bit more. Why do we need to subtract 5 minutes?
Because the hiker doesn't stop. So the hiker is also traveling for 5 minutes. So that have to be subtracted.
Yeah, that's a valid point. So for 5 minutes, the hiker has already been walking. Right. And you did a smart thing. What we could get into that at that point is, oh, let me figure out this distance. In 5 minutes, how much distance would the hiker have covered? And then what is the remaining distance? And then that distance divided by the speed. But you understood that anyway, no matter what the distance is, that much distance would have been covered in 5 minutes only. So yeah, then from this point, it's a matter of subtracting 5 minutes. Indeed, the correct answer is 20 minutes, not 25. Yeah. Okay. So again, nothing wrong with this, but let's see how else could we understand the problem. So stay with me, Ashima. Who's faster?
The cyclist.
Cyclist. What are the ratios of their speeds? By what factor is the cyclist faster?
5 times.
Cyclist to hiker, the speeds are in the ratio of 5:1.
Yeah.
Therefore, what will be the ratio of their time taken?
1:5.
They're covering the same distance, the time will be in the ratio 1:5. So for that, I'm talking about the whole distance from meeting point all the way to waiting point. This whole distance was covered by the cyclist in 5 minutes.
Yeah.
Right? This whole distance.
Yeah. So hiker will take
hiker will take
25 minutes.
25 minutes. Right? So 5:25. But this is for the full distance. Now we do the last step that you did. Oh, but the hiker has already been walking for 5 minutes. So from this 25 minutes, we just need to subtract the 5 minutes. And we get the answer.
This is much quicker.
Does it make sense also?
Yeah, much faster also.
Yeah.
Yes.
So what I do, and this is what I recommend also, whenever you look at either one person traveling two segments or two different people, speeds are given, things like that. I start off with understanding who's faster, who's slower, and what's the relation between them, right? If nothing else, just to understand. And then in this case, in fact, from that, I understood, oh, the speeds are in the ratio 5:1. The time will be in the ratio 1:5. One guy took 5 minutes, the faster one, the slower one will take 5 times that time, right? So actually all this could be done, processed mentally also. Again, that doesn't make the question, that doesn't mean that it was an easy question, because the difficult thing was to, in fact, just get initiated and go in this direction. Now realize this is what we've been building towards. The instinct that we have, oh, as soon as you see a question, you start thinking about, okay, distance equals speed into time, and then start kind of solving the problem in a traditional way. Anna? That's the difficult thing here. How do you even start thinking of things like that? But once you start thinking, then for many questions, things will start falling into place. By the way, 25 is, I don't remember whether it's more common than 20 or not. I don't think so, but still a very common answer on GMAT Club for this question. So basically, many people miss that bit about, oh, the hiker would have been walking already also, right? I believe one reason for people missing that is that while they're reading, half their brain is already, or a portion of their brain is already thinking about the solution. So they're not focusing on understanding the problem wholeheartedly. And if there is a complexity in the question, it's not like the complexity will be in a different font or anything. It's our job to read the question properly to make sure that if at all there's any complexity, we understand it, right? That's where the problem starts from. That maybe while we're reading, and I can't be sure, but I've seen this with a few students. I believe that this is the case with at least a few, that while reading already, we are processing other things also. And then we maybe miss, and maybe because of that, we equate this, how many minutes must the cyclist wait? Already we equate that with how long will it take the hiker to cover the full distance, right? Whereas this is very different. What they're talking about is how long will he wait? So his wait time will start after he's reached there. So his wait time will start after 5 minutes, basically.
Yeah, exactly this. Yeah. I just concentrated on how much time will it take to cover the distance. True.
So the follow-up questions become, one is, what mistake did I make? Oh, I equated the wait time to the time it would take to cover the distance by the hiker. But that's what mistake. The follow-up becomes, why did I make that mistake? Right? That's kind of I was trying to highlight. And oftentimes it is related to exactly what's going on in our mind, right? It's not like, oh, I misunderstood the word wait to mean how long it, no. I'm sure you read it properly and then you interpreted that to mean the other thing, right? But why did that mistake happen is the question to ask them. Because only then can we understand how can we avoid making such mistakes in the future. Yeah.
But how can we avoid?
I mean, no, that depends on why you're making the mistake.
Okay.
And it's not like every time you'll get a clear-cut answer to that question, but that's the question to really think about, right? Why am I making this? Or why did I make this mistake? Did I read it incorrectly? No, I read it correct. I'm sure I read the words, how many minutes must the cyclist wait? Right? Did I pay enough attention to this? If not, why not? Was I solving parallelly? Was my mind also thinking about how to solve? If that's the answer, then perhaps the solution is, okay, I will make sure I just first read to process the questions separately and then get into solving. And I will not try to mix the two things as I do sometimes and I end up missing things. Right? So for the follow-up question, how to avoid such mistakes, the previous question is important. Why did I make the mistake? That answer will tell you how to avoid.
Right.
I can't guess for you what your reason might have been, but yeah, that's what really needs to be probed. Chalo, let's try one more. Yeah, go ahead. So before I discuss this question, I want to go back to a question. In fact, we did at pretty much the very beginning of yesterday's session. I had presented these three statements, and we had discussed the first statement alone was sufficient. This is not a DS style question. There are three statements here, but separately, if you look at the statements, the first one was sufficient. Right? I won't go into explaining again why. It's part of the video already. The second one was not sufficient. The third one was also not sufficient. So I want to focus on the third one. The average speed had been more by a particular value, and the time had been less by a particular value. I'm saying based on this, we could not figure out the actual time. But with the first statement, if the average speed has been more by a particular multiple, 3/2 times, and I'm given the actual time in that case, I can figure out the time it would take in the original situation also. How? Because if the time goes up, if the speed becomes 3/2 times, the time will become 2/3. So 2/3 of the time is 2 hours. So the original time would have been 3 hours essentially. Right? Basically, if I'm given a multiple of the speed, then I can figure things out. Right? If speed is, instead of x, it's 3/2x, time will be 2/3x. That helps me. But if the speed is 30 kilometers more, that doesn't tell me, oh, the time will be less by this much. Right? And even if I know that the time is less by 1 hour, as I discussed yesterday, I can't directly comment on how long it would take overall. Right? There can be multiple different situations in which this can happen. So now, look at this statement here and look at the first statement in the Khalil example. Very similar. If the speed was more by a particular figure, the driving time would have been lower by a particular figure. So one instinct might be identical, therefore not sufficient. But there is a key difference between this statement, this question, and the other one. In the Betty example, I don't have a complete distance. In our case, we do know the total distance. Whether it makes a difference or not, we'll see. But there is a difference between the two cases, between the two questions. So I can't just directly decide, oh, because in the Betty's example, the third statement was not sufficient. Here also, the first statement will be not sufficient. No, can't just directly say that. Chalo. We'll spend some time on the first statement. Before we do that, though, let's deal with the second statement here. This is now identical again to the second, or rather a similar style of statement as the second statement in the Betty's example that we discussed yesterday. Right? This is an identity. If the speed is 3/2 times, the time will be 2/3. This is always anyway true. This is not something new for us. Same principle here also. And we discussed this as well with percentages, right? If the average speed was 25% faster, basically, if the average speed was 5/4 times, the time will be 4/5 of the old time. So 4/5 does mean reduced by 20%. So this is again an identity. If the speed goes up by 25%, the time has to come down by 20%, no matter what, for the same distance. So this is not, oh, wow, I've learned something important here. No, this is something which I already knew. This is always true. Right? Again, it's like saying 1 is a positive number. If it's something that I already know, something that's an identity that I can directly apply, how can that statement be a helpful statement? Right? So the second statement here is not giving me anything that I didn't know from before. The second statement anyway alone cannot be sufficient. Therefore, D also can't be the answer. Not just that, there's no way I would need to combine the answers. Why would I need to combine a universally true statement with the first statement to figure out the answer? Right? This is something I already know, that yes, if the speed goes up by 25%, the time has to reduce by 20% only. So the second statement doesn't give me any additional value. Why would I even think about combine? So if that much becomes clear to me, even if I were to blindly guess, or not blind, even if I were to make an educated guess, I would choose between A and E. Let's say the first statement is not clear, or let's say I'm running short on time. Either way, the answer has to be A or E only. The only thing I applied to get till this point is realize that, oh, this is something that is obviously true. The second statement, right? This is nothing new. Not just B and D, C also gets rejected in this case. Why would I combine the first statement with something which is universally true? So either the first one alone will be sufficient or it won't be sufficient. That's the situation. That's it. That's one. That's kind of step one. All right. Now let's process the first statement. If Khalil had driven an average speed that was 5 kilometers per hour faster, his driving time would have been reduced by 20 minutes. So if nothing else, let's just start with some examples to try to understand exactly what's going on. So I want to try some numbers which are easy numbers. Easy how? I would need to calculate the time. I would need to divide the distance by the speeds. So I want the two speeds that are both easily, that are both either factors of 120 or still I can somehow easily manage with 120. So I'm thinking if I take 20 and 25, okay, 20 is a factor of 120, 25 is not. So at least as a starting point, I don't like these numbers. 60, 65, no, 65 is not a factor of 120. So that leads me to think about 5 and 10. 5 is also a factor of 120, 10 is also a factor of 120. Basically, I'm looking at numbers in which one number is 5 kilometers per hour or one speed is 5 kmph more than the other speed. So then I'm thinking as an example, if the two speeds are 5 kilometers per hour and 10 kilometers per hour, what would be the situation then? 120 kilometers at 5 kilometers per hour is how much? 120 divided by 5 or 240 divided by 10, that's 24 hours. At 10 kilometers per hour, it'll be half of that, 12 hours. What we know is that the actual time reduction is by 20 minutes, by 1/3 of an hour. Right? So what I know so far is that 5 and 10 can't be the answer. 5 and 10 can't be the speeds. But my job is to figure out whether statement 1 is sufficient or not. So I'm not even clear whether I can get an exact value or not yet, let's say. I'm still trying to understand, okay, how does it work? What's going on here? So let me take, this is one example. Let me take another example to see what kind of story I'm getting. So again, I want to think of some numbers in between which the difference is 5 and they are both factors of 120. So after thinking for a little time, I was able to come up with 15 and 20. So let's say the speed is 15 miles per hour, 120 kilometers at 15 miles per hour, 150 by 15 is 10 minus 30. So 10 minus 2, 8 hours. 20 miles per hour, 120 by 20, that's 6 hours. So I do notice that the difference has come down. Earlier, the difference was of 12 hours. Now the difference is of 2 hours. So now I start thinking, this does make sense. That as the speeds keep increasing, let's say 20 and 25, 25 and 30 and so on, the difference between them will keep reducing. Right? If I'm traveling at, let's say, 1 kilometer per hour, then I will take 120 hours to cover the whole distance. Compared with that, 6 kilometers per hour will be 20 hours. So significant difference between 120 and 20, 100 hours difference. Basically, as the speeds keep increasing, the times will keep reducing, both the times. So, or another way to think about it, 1 kilometer per hour versus 6 kilometers per hour is a 6 times difference. So the time will also be in the ratio of 6:1. But if the speed is, let's say, 1000 kilometers per hour versus 1005 kilometers per hour, now the difference of 5 kilometers per hour doesn't really mean much, right? If the base is so big, 1000 and 1005 more or less the same, but 1 and 6, huge difference. So yeah, as the speeds keep increasing, the 5 kilometers per hour essentially doesn't have as much of an impact, right, as it does initially. In 5 and 10, that difference has an impact of 12 hours. In 15 and 20, the difference has an impact of 2 hours, right? They were able to save 2 hours like that. So what I can understand is that as we continue 20, 25, 25, 30, whatever, I don't even know whether there'll be multiples of 5, the speeds. But basically the sense I'm getting is that in each case, the difference will keep reducing further and further. So there will come, as far as the data sufficiency question is concerned, there will come some point somewhere in the middle where the difference will reach exactly 20 minutes. Beyond that point, the difference will go even further down. Let's say, for example, the speeds are actually 1000 and 1005 kilometers per hour. Or chalo, let's make it 1200 kilometers per hour. So 1200 kilometers per hour, 120 kilometers means 6 minutes. Right? So 1205 will be slightly less than 6 minutes. There's no way the difference between 6 and something slightly less can be 20 minutes. Right? So the difference will keep reducing until at some point the difference becomes 20 minutes. And beyond that, the difference will continue further reducing. So there'll be exactly one pair of speeds only, such that the difference between them is 5 kilometers per hour, and such that the total distance is 120 kilometers, that the difference between the times will be exactly 20 minutes. There'll be only one such pair of numbers. Before that, the difference will be more. After that, the difference will be less. As far as the data sufficiency question is concerned, that's enough. That's enough for me to figure out that this first statement is sufficient. On the exam at this stage, I could mark A and move on. I'll take a pause here first. Tell me, is this much clear?
Yeah.
Yeah.
All right. So how to, if I were to figure out the value also, the average speed, how to go about it? I mean, we could think of it mathematically, but again, I was more inclined towards thinking of pairs like this, right? With 15 and 20, I got to a difference of 2 hours. So I thought, okay, I have to keep going further. And the difference has to be of 1/3 of an hour, right? That's the key. 20 minutes is 1/3 of an hour. Since the speeds are in kilometers per hour, I'm thinking of the difference also in terms of hours. So then let's try to do that. 15, I'll write this one again. 15 kilometers per hour, 20 kilometers per hour. 15 is 8 hours. 20 gives us 6 hours. The difference of 2 hours. Chalo, let's take, for example, 30 kilometers per hour and 35 kilometers per hour. Now I'll start getting into some non-integer numbers, but anyway, yeah, the difference has to be of 1/3. So anyway, one of the times will be a non-integer. But still not a very messy non-integer, right? This is a difference of 1/3. So 30 kilometers per hour would mean 4 hours. 35 kilometers per hour, 120 by 35. How much is 120 by 35? The question is it 3/2 or not? Right? Even here now, it's not a matter of, oh, I have to calculate the value. The question is, will the difference be 20 minutes or not? 20 minutes difference. At the faster speed, basically, they'll need to take 20 minutes less or 1/3 of an hour less. So the time should be 3 2/3 hours. Is it with 120 upon 35? Well, okay, let's calculate it. So 35 into 4 is 140. That's too big. So this is 3 point something. So not a bad start, actually. So 35 times 3, 105. I'm left with 15. 15 by 35 or 3 by 7. I need 3 2/3. I get 3 by 7. So I'm close, but this is not exactly correct. So let's try 45 and 50. 45? No, let's try 40 and 45. At least one number would be a multiple. So 40 kilometers per hour gives me 3 hours. 45 kilometers per hour should give me 2 2/3. What does it actually give me? 120 upon 45. 45 times 40 times 3 is 120. Oh, so I'm at 2 point something. Okay, that's not bad. Yeah, good start. So 2 and then 90, 30 by 45, 2 2/3. Oh, this one fit actually. I hadn't calculated. I didn't expect this to be the answer, or I didn't know whether this would be the answer. 40 kilometers per hour, 3 hours, 45, 120 upon 45, 90, and then 30 by 45, 2. Yeah, nice. 2 2/3. This one fits. To confirm, let's try one more. 60 kilometers per hour, 65 kilometers per hour. This one is 2 hours. 65 kilometers per hour, 120 upon 65. This is 1, and then 55 upon 65. So 111 by 13, right? What I actually need is 1 2/3. What I get is 111 by 13. Notice now the difference is reducing further. The difference between 2 hours and 111 by 13th of an hour is less than 20 minutes. So yes, now I have found a pair which gives me that exact difference that I need. All pairs before that had a bigger difference. The pairs after that will have a smaller difference. So these are the values. The answer once again to this question is A. Now, see, this principle actually is a very much more fundamental principle than just time, speed, distance. Basically, when I have speed into time equals a fixed value, in this case 120. So if I play around with the two, if I make this s plus something and then I make this t minus something, right? So I will be able to figure out what s and t are. Essentially, I have two equations, two variables. I will be able to figure things out. I had the speed is increased by 5 kilometers. The time is reduced by 1/3. This is also 120, right? So I could figure out mathematically also what the speed and time are. If I'm just given that s times t is equal to s plus 5 and t minus 1 by 3, but I'm not given that they're what the values are, that's an issue. If I'm not given, oh, they're both equal to 120, that won't be enough, right? But if I am given, oh, they're both 120, then at least I can get somewhere. So let's wrap up. Tell me then, what have been your takeaways?
My biggest takeaway has been the power of weighted averages across many topics.
Yeah, you're right. That's one such topic that a lot of questions obviously have the language, what is the average, what's the weighted average and all that, where anyway that can be used. But many questions in which it's kind of a hidden underlying concept, right? The language would not show you that, oh, weighted averages can be applied, but it can be applied. Yes, you're absolutely right. So these last questions that we discussed, I don't remember the percentage, but definitely hard questions, right? 75, maybe 85 or 95% even. So definitely hard questions. And as we discussed yesterday also, that we'll try to apply the things that we've already discussed in some very hard questions. The hiker and cyclist question, if I remember correctly, is a 75% difficulty question. So the main or one of the big things I want to highlight is that don't wait for that difficult, tricky question to start thinking about things in a logic-based fashion. Right? Often what happens is whenever you can apply a traditional approach, you apply that, or students do that. And then if and when they get stuck, then they start thinking, oh, this question could have been answered using reasoning. How come I couldn't think of it like that? Because they have not been developing their skills of reasoning. How to develop your skills of reasoning? Don't wait for those complex questions, which are anyway very difficult. Start developing them with easy questions, which perhaps you could answer using a traditional approach very easily also. Sure. But use those questions to develop your skills of reasoning so that you can actually then apply them in easier questions also, and you can apply them in harder questions as well. Again, whether you eventually do it on the exam or not is a separate matter. But I'll repeat something that I said yesterday. You're not taking anything away from your arsenal. Right? The objective of this workshop was not that, oh, algebra is bad, forget about algebra. No, the objective is that, oh, okay, maybe you're already comfortable with algebra, and in my opinion, maybe too comfortable with algebra, as is true for many people. Now, maybe you start getting comfortable with an alternate way also, so that you can then choose. You can decide based on the question, based on your situation as to what you need to do. And it's not forced upon you that as soon as you see a question, you have to start creating an equation only. And in order to do all this, in order to develop this skill of reasoning, of noticing such things, before anything else, step one is patience. Because if you're rushing through practice, if your objective is, oh, today I have to practice 100 questions, today I have to do this whole book or half the book or things like that, then you won't take the time going deep into a single question. Right? So that's perhaps the starting point anyway, before anything else. Are you anyway being patient? Are you giving yourself an opportunity to learn and improve? Or are you just focusing on executing things that you already know? That's not the way to improve. Right? If, for example, you do a question, you get your answer correct, and you move on to the next question, then what have you learned through that exercise? Maybe you've developed some confidence, fine, but what new thing have you learned? You've just executed things, you've just applied things that you already knew. And the foremost objective of your preparation is learning. Improvement will happen through learning. There's no alternate. Right? So that's the question I would ask whenever I'm practicing. What did I learn through this question? Or what can I learn through this question? For that, again, step one, patience.